All right, everyone. Thank you so much for joining us. My name's Stacy Block. I work in the Innovation Division with John Watson at San Diego County Office of Education. We have our third session for you today. This session will be looking at which tool and when, a comparison of RStudio, Git Hub, Jupyter Notebooks, Python, Power BI, Tableau, Docker, and Knime. And we have Nick Chitwood here, Dr. Nick Chitwood, and he'll be explaining and going through these tools with you. And thank you, Nick, for being here from the Riverside County Office of Education. And I noticed that he put a bit.ly in there, and we'll continue to put the bit.ly in the chat as new people join the session. So take a moment in the chat, introduce yourself. And again, if you have questions about any of these tools or you have resources yourself, feel free to share it in the chat. Thank you so much for collaborating and participating today.
All righty, well, we'll get started. So hopefully I scared off the people who know more about this than me. So the intended audience for this is that if you're interested in the broader data science tool set, but haven't invested a ton of time in a particular set of tools, or if you want to hear a brief sort of introduction to some of these other tools than the ones you're currently using. So having so many tools on this list, we're not going to have time for depth on any of them, but we will hit them briefly. So here's kind of the reality, right? Like the presentation title implies this, and this is, actually this might work in Python, but it's like, we sort of think we would love to live in a world where if you're user X and your need is Y, this is the tool you would use. If you have a different need, then you use that. Otherwise, just use Excel, right? But here's kind of the reality is that, you start bringing in issues of the budget and there's multiple tools that overlap. So, and hopefully we never get to the else statement in this. Please don't give up and forget about it. There is a tool out there for you. So sort of the thing that framed my thinking around this when I first started this presentation is like, what are those sort of key tasks for data practitioners? So it's data manipulation, transformation, exploring the data less formally, maybe modeling and analysis, and then visualization and presentation. And so let me tell you a little bit about my analytic journey, and then I'll get into the tools. So I learned to use these tools as part of grad school, but I did a lot of tool hopping, as you can see. So my first course in statistics was in SAS. If any of you have worked with SAS before, that's all I have to say about that. But then the program, the reality is most social scientists are using SPSS, I think, as their primary tool set, at least in the time in which I was doing this. So SPSS is more of a point and click sort of statistical package. I heard this cool thing about using more scripting based languages. So I actually hopped over to Stata for most of the rest of my grad school experience and master's and some of beginning doctoral. But then eventually I made it to R. And then since grad school and in the workforce, I've done more Python to learn it and I'm actually doing some web development in it. And so I'll talk about these sort of different use cases. So I've done all the statistical things here when it comes to these programs. But before I even get there, I want to talk about Git. So what is Git? Git is not really one of those data science tasks necessarily, but it's a tool for what we call version control, and it also facilitates collaboration. So you can see this image on the screen. And in fact, I think my dissertation actually looks like this, in that I have multiple Word files, different drafts, and that was more me taking a snapshot of it. So that's one model of version control that we all know and I wouldn't say love. But what Git actually does is along the way, you can take snapshots, you can branch off and explore other things, then you can merge those things back together in order to keep a better running record that stays with you. So some key features of this is that changes are made to files in a project and you save them each time a commit is made. You can even experiment. You can try new things in a project and you can always revert back to the last saved state. Another aspect of this is Git can be entirely local. You can just version control your own local work, but you can also connect with a remote repository. So I have some visualizations in my presentation, and I put links to where it came from. And now here's where we're going to do a little bit of juggling here, because my embedded animations aren't actually working. So what I'm going to do is I'm going to have to pull them up here. So you're going to see a little block here, and it looks like you can't see anything. So just bear with me as I get this up. And of course, it's not going to let me choose from Chrome. Chrome, where are you? So, you know what? I think to save time, I'm just going to actually click my own links. We're going to do this the old-fashioned way. So, so the first animation I was going to show you is what does it actually look like when you do a commit? And here it is. Let me zoom this in here. Okay, so you do your writing, and then you issue some commands, and now you've made a commit. And that commit is hashed, so that's how it identifies it, is it just comes up with a pseudo-random sort of representation of it. It's not really random, it's deterministic. But then you do some more stuff, you make a new commit. And so now you have both versions that live in your folder, but you only actually ever see the current version. If you ever revert or go back to a previous version, it'll pull it out of a hidden folder. So you can see we'll make another commit, and bam, you've version controlled. All you see is the current document, but you can always go back to the other ones. So, and I know Steve right now, my colleague, is judging me for having a presentation not taking full screen, but it's just the nature of what it is. So let's say you make a couple commits, but then you realize, boy, that was a big mistake. I went way down the wrong path. So then what you might consider doing is a revert, or this is a reset, actually. There's some more technical details to this, but we can't get into that, not with the time I have. But some visualizations of some of these Git things would live here. So if we were to try to revert, this is what that might look like. So all you do is you just hit Git reset, and you know those snapshots we took earlier, they're gone. You're back to where you were. It's like a massive undo on your whole project, okay? Another sort of thing you might consider doing is pulling. So let's say we have that remote place we're storing it. Most popular location where that would occur would be Git Hub, though it could be anywhere. It could be GitLab. What that might look like when we do a Git pull is right here. So you go to what's called origin, or the remote repository, you git pull, and now you're caught up with whatever happens on the remote. So that's where, so you've got the version control, but you also have the collaboration bit. If multiple people working on a project have access to that remote, they're going to be putting things on that remote, pushing it, pulling it back and forth is the terminology. And so you can collaborate on these sort of projects. So like I said, the origin is the remote repository that's shareable with other members of the team. Is this still sharing? Just double checking. Silence is good. So
Yes. Yep.
Some of the most popular public repositories are GitHub and GitLab. And now one caveat about this is you can version control anything. You can version control a massive zip file, though GitHub will get mad at you if it's over a certain size. But version control really excels with plain text. And so if you're working with an Excel file, what you'll get is just the newest version of the Excel file. But let's say you're doing a script in R or Python, you'll be able to actually, in the interface, see the comparison of what changed, what lines of code were deleted, what were added, and what those changes might have looked like. So that's Git. That's all you get on Git. And we're already 10 minutes in. So there's some official documentation there if you want to play with Git in your own local setting. There's these downloads here. I'll go back into present. I didn't need to jump out yet. And here's some other sort of places where you can play with Git. Okay. Any quick questions on Git before we get on to the next topic? Lots of puns available with Git too, so that's another reason to adopt it. Going once.
Don't see question.
Going twice. Okay, so GitHub, Git, now you know all about it and why it's useful. Okay. So if you walk away from this session knowing that, I mean, you probably already knew there's just a whole wide world of tools out there. So it's a combination of balancing time, reproducibility, cost is big in education, though we know that there's a lot of money coming in, easy come, easy go, and your audience. So here's one possible schema in which you might choose what to use. So tools can operate in text or with a graphical user interface point and click. So Python and R as programming languages or scripting languages might be in the text world, whereas Excel, which we know and love, or Knime, would live in the graphical world. So what I'm going to do right now is I'm going to play a short video of me doing the same exact thing in those different tools, except for Knime. I didn't do Knime. That's a lie. So between Python, R, and Excel, what would it look like to take some, here's some test data. What's the average score overall and by gender? And then let's say I want a histogram to see the distribution of the results. Okay, so Excel, this should be pretty familiar to you. So now I'm gonna have to share that. So I know you can't see it yet. Hopefully you can see it now. Do you see a wonderful Excel spreadsheet?
Yes.
Alrighty, so so you can see here I am. I'm putting in my data. Hopefully you have an export from your data system, but let's say you're doing it by hand because you live in the 20th century. So you're typing in the results, got your, you put in the gender, you got some scores coming your way. This part's slower because I'm not as good a typer at this apparently. I mean, this should be pretty familiar, I think, to most people have done this sort of work in Excel. So now I want the average, so I'll do a formula. By the way, if you do this in Excel, you're already a programmer. So don't fool yourself into thinking you're not a programmer. You just program in Excel, which, for what it's worth. Now I want the average of male students, so I find another function. So I'm going to use average if. I had to think about which thing to drag over. So that's the range that I'm going to check for male. And then the actual data I'm going to average is here. So I drag over that. And bam, I have my average male performance, 69.4. Now I'm going to get the female version of that. Now, of course, whenever you copy down, it messes with, I fast forwarded through me making some mistakes there, but I had to adjust the things back up. Here's my histogram, and Excel decided that 2 buckets was the best number of buckets for some strange reason. I don't know why. I fast forwarded through me fixing some of that. Oh, look, and I made more buckets, but the bins were kind of weird. So now I made it to bucket, so 10. And now we have a logical histogram for our data. So there we go. Oh, and I have to make the title good, apparently. So Excel, was fine. This took me, well, it actually took me like 5 minutes, and I fast forwarded through me messing up. And there you go. So now we have some averages. I guess it's not going to let me back up. That's fine. You don't have to. Windows. So we know the average. We saw that females did a little bit better. We have a histogram to show distribution. Granted, with only 10 kids, it's not that helpful. Okay. So comments. So once again, it's not purely point and click. You can type formulas in. Now, reproducibility is a little bit harder. So if we have the number of students the same and the columns stay the same, and what's the story in sharing the results with others? Well, actually, this is good, right? To the extent that I can share the Excel file with almost anyone and they'll be able to take a look at my data. Okay, so this is not going to be an Excel bashing session, just a little. Okay, so now let's use a different tool. I think the next demo is R. So I'm going to show you the same exact task in R. Okay. I skipped over the part where I installed R on your computer for you and did all that. Okay, so R is text-based, as you recall. Okay, so I went into my PowerShell terminal, R. I'm in R. So now I'm going to enter my student data. Now I copied and pasted it in. So you can see I've got an array of the students, the gender, and then their results. And then I combine them all into what's called a data frame. A data frame is just a table in R sort of parlance. So now the data frame has those 3 columns. And then what I get to do is if I want to get the average test score, R has a function built in called mean. So I said, take the mean of the test column score. Okay, now if I want to get it by gender, the filtering syntax looks like this. So I say, take the test gender and check to see if it's equal to male. And then because of auto completion, I just hit the up arrow, and now I'm going to do the same thing for female students. And we get the same data back. We can see, as usual, our female students are doing better. And then if I want to do a histogram, I can just do a histogram of test score. And it didn't work at first because I was having issues, but I fixed those issues because it's entirely in a terminal. It's a little clunky, but what I was able to do is eventually I got it to work. And so you can see here's the plot. It magically put it into a PDF. And now here's the histogram. So there was me performing the same exact task, except this time it was in R. And here's our histogram. Okay, magic. Not magic, deterministic. Okay, so let me go back to my presentation here. So there you go. I did some basic data analysis on my tests in R. So R is fundamentally a statistical programming language. Its heritage goes back to a language called S, and I guess they were being clever and called it R. And the nice thing about R is because it was built for statistics, many essential mathematical and graphical functions are built in. So if you install R, you can take an average, you can make a histogram, you can do differing plots. Before I move on to the next package, is there anything I need to talk about in terms of Excel or R, or any comments or anything yet? Alrighty, so I'm going to jump into doing the same exact thing now in Python. So Python is also text-based. So here I go to do it in Python. Okay. Now what you're actually going to see me do first is, even though Python has what's called a robust standard library, I actually can't do statistics in Python as it comes out of the box. Well, okay, I take that back. You can take the average and median of something, but besides that, it's pretty bare bones. So first thing I'm going to do is I'm going to install Pandas and Matplotlib. So that's going to be my statistics package, and that's going to be my graphing package. And it happened really fast because I already did it and then uninstalled it for the presentation, but it's going to go off to the internet and it's going to pull down those packages. So now I jump into Python. Yay, Python 3.9, the new hotness. So I'm not in the most recent version. So now, once again, I'm just copying and pasting it in. You can see the syntax is a little different. I have to use brackets instead of parentheses. I don't have a C in front of it. It doesn't have the fancy schmancy arrow. It just uses equal for assignment. Here's the genders. Here's the score. Okay. So now I have to import pandas because Python doesn't know what to do with those are called arrays, and it doesn't know how to do any statistics on them in and of itself. So I'm going to import pandas. I'm going to import Matplotlib. And this thing I'm actually pulling in is a function so that I can get output. Because once again, I'm only in a script environment, so graphical things go weird. I promise it gets easier, but this is like the most bottom level implementation of something like this. Okay, so now I'm going to make them into what's called a dictionary, and Pandas is going to take that dictionary and turn it into its version of a data frame. So here's our data. Looks like the Excel table, except it's in a text environment. One other thing to note, it's just one of those quirks of programming, is Python is a zero index language. So the first row is row 0, and it's just one of those things you have to get used to in Python and other programming languages. So row 0 through 9, here's our 10 students. So now Pandas. It's a little bit different in terms of test. So you can see here's our test data frame, here's our score, and we're going to apply the mean function to it. And now what we're going to do is we're going to subset test. Pretty similar sort of syntax here. So we're going to take test, we're going to filter it down to just male students. There was an oops there. Then I'm going to take the score column and take the mean, hit up arrow. Now I can switch that to an F. And here's our female mean. And now here's the histogram, and I'm going to pre-specify the bins. So I'm going to tell it where to divide up because it doesn't do it very smartly on its own. And then, so it made a plot. I'm going to tell that plot to save it to save the figure. It's going to save it to a file called score. And then you're going to watch me click through to the right folder, even though it's right there in the sidebar. That was a waste of my life and yours. And here it is. Here is the Python version of that same histogram. Now, I think because of how I did the buckets, it might be including kids who have a 60 in both, so I'd have to finesse this histogram a little bit to make sure. All righty. So there is the Python implementation. And I will go back to my presentation. And we are 20 minutes in. Okay, so Python, it's a general purpose programming language, but it's become popular with data scientists due to its flexibility and ease of learning. So like I said, basic statistical functions beyond mean and median are not included, and plotting is not even included in a default installation. You can do text-based plotting, but it's very clunky. So Python requires more finessing to install, though there is a wider range of possibilities in Python. So this is a XKCD comic. And so the caption is, "You're flying, how?" And the response is Python. I learned it last night. Everything is so simple. Hello world is just print hello world. Now in Python 3, you'd have to put parentheses around that. Dynamic typing, white space, blah, blah, blah. So how are you flying? I just typed import anti-gravity. That's it. And you can read the rest. So with R and Python, there are a bunch of packages out there. And basically, if somebody has thought of trying to do it, especially in Python, there's a package to help facilitate it. You can build it yourself, or you can import someone else's implementation of it. So, okay, let's do a quick reality check though. Very few programmers, much less data scientists, really do a lot of programming in just the terminal. So I showed you, this is the bare minimum implementation of the language. There are some hardcore folks who will do it in Vim or some other text-based thing and maybe do a couple plugins. But languages are often utilized with a GUI, or graphical user interface. So two types of GUI I'm going to show you right now is an IDE, or what's called an integrated development environment, or in notebooks, which are web-based. They occur in the browser, sort of. Okay, so what are the advantages of the IDE? So you can easily interact with the file system to save your scripts, and it's more graphical. And then you can also more easily examine data structures and plots within that same environment. So now I'm going to show you the same analysis, but this time I'm going to do it in RStudio. Anything while I'm pulling that share up that I need to respond to?
There's no questions. Feel free to use the chat.
Yeah, okay. And this is pretty straight. I mean, the whole point is that hopefully this is all making sense, because if not, I'm not doing my job with the sort of surface level thing I'm doing here. Okay, so here's the RStudio version of it. So what I've done now is I actually have a file in which each of those steps is already in there. So the nice thing about it is you can save your work as a script. So what I did before was the interactive mode. This would be more of saving it as a script. So here's my students, and you can see it occur in the bottom. Now the other cool thing is, because we're in RStudio, as I do these steps, not only does it happen behind the scenes, you can actually see what's called the environment. So over in the top right corner, you can see the data as it's saving it into memory. And now as I perform the analysis, I'm going to do, oh, and there it is. And then you can even click on the data frame and you can examine it graphically. You see there's a little filter button up in the top. So if you want to do some basic filtering of it, you can see it. So already layering on RStudio or another graphical user environment has given you a broader ability to interact with your data. So why RStudio? Because it's definitely a lot easier than just working in interactive mode in a terminal. Okay, so now I want to do the average. So let me do the average. Okay, so here's my average test score. You can see that's showing up in the console down to the bottom left. And I'm going to do my histogram. And now I don't have to go track it down in, okay, you know what, actually I'm thinking on the Python, it's how it decides if, because some of these numbers are exact, right? So there was a 60. So it decided in one program to put the 60 in this bucket, in the 60 bucket, and in others it did not. Anyways, just a quick reflection. So now you can see, I can see my plot all in the same place. And boy, am I happier. I don't have to deal with like going in the file system to track things down. I can save my analysis, and now I can go back and do it again. Okay. So, so that's a IDE. That's one way to do it. A notebook is another way to use the same languages. So you can do interactive exploration of data while maintaining a running account of that exploration. So RStudio has notebook functionality. And Python can be explored through Jupyter, which you install on your computer. It creates a local web browser and it interfaces with Python. Or another cool place where you can do this without having to do any installation is through something called Google Colab. So Google's Colab is an implementation of Python notebooks. So let me show you. You can see my recent Google searches too if you're nosy or just interested. Google is definitely interested in my data. So here, let me show you what Colab might look. No, if I did this, I put these in the wrong order. So let me jump ahead here to Colab because my presentation thought I would do Colab next. Colab, where are you? Okay, so here's the Colab demo. Okay, colab.research.google.com. Make a new notebook. Okay, so I'm going to do that same Python analysis, but now I'm doing it in a notebook. So the nice thing about notebooks is you can intersperse sort of presentation content or sort of headings along with code. So here's my awesome Python notebook. Now I'm going to put my data in. So off screen, I happen to just have it ready to copy and paste. You hit play, and now it's saving that data. So now what I'm going to do is I'm going to create the data frame. Actually, I'm not, because I have to import those requirements. Remember that Python, when you open it, doesn't have access to Pandas, which is the data science sort of Swiss Army knife, nor does it have access, and that's all I need, because I don't need to mess with the Matplotlib library because it's going to show up right here. Okay, so now I have my sort of columns. I'm going to create my data frame. By the way, if you've never used Markdown before, those little hashtags or pound signs, as we called them back before Twitter, they create headings. So I've created a dictionary with the 3 columns, and now I click it because it's not showing up, and then I realize, oh, it's not going to show me the data frame until I hit test. And now, boy, that looks prettier already, doesn't it? Because it's working in Colab. So now I'm going to get some means. So what's nice about this is I've got a running log of my data exploration as I go. So now I've got my overall mean, I'm exploring my male mean, and now I've got the female mean. And then I'm going to do my pretty histogram and a plot. Boom. And there it is. So yeah, you can see here. And then if I want to print it, I'll click the print button, and there it is. So I can save it as a PDF, and I've got sort of a way to export my work. So that's why you might use a notebook. Notebooks are great for sort of interactive data, data exploration. And then I'll show you the same thing in our Python, or not our Python, that is just me mushing two things together, don't get together, in RStudio. So we'll go back to here. Nope. Okay, so now here's an R notebook. So it's pretty similar. You do the code in here, and then there's no output from this because it's all just assigning things in the background. And then maybe I'll make another sort of code block here. And then I had bad grammar, so I felt compelled to correct it. And then you might do the means at that point. And you can see the results pop up underneath once again. My computer is very helpful in reminding me 30 minutes into my presentation that I have a presentation. And then here comes the plot. So I do a histogram, remember and the other, oh, here's something that I didn't get to show much of because I copied and pasted it in. So the other advantage of IDEs is something called auto-completion. So if you noticed, it popped up things that I might be interested in filling in. So it speeds up your workflow to use an IDE as well. And then the last thing I'm going to show here is I made a PDF, and in this case, it's using LaTeX to go to PDF, and now it's a very nice document. You can see here is the output, and you'll see the plot on the next page. So if you're interested in doing reports, you could, one of the things I don't show is importing outside data. But let's say you had something to import and export from your data management system, then you could make this report. Maybe you divide that up by each school, by whatever sort of setting. So now you have a way to create reproducible sort of reports that look pretty decent out the box. Okay, so back to the presentation. So
we have a question.
Here's kind of the tricky part. Oh, yes.
Yeah, real quick question. So for Python, is Pandas the standard go-to tool for manipulating data, or are there other tools?
I would say Pandas is where all the energy is. So so my fallback is R because that's what I did my grad work in. As I get more and more into using Python, I need to learn Pandas. Like that's kind of where it's at. And then under the hood of Pandas is a library called NumPy. So even like the sort of matrix multiplications and all the sort of fancy sort of things that support statistical analysis occur at an even lower level, but Python doesn't have that built in. You don't have to learn NumPy though. So yeah, Pandas would be where you would need to kind of learn the sort of interface and how to work with it. Okay.
And then there's a follow-up.
So now here's the thing that makes, oh yeah.
Yeah. Are there other packages besides Matplotlib that you use or recommend?
So Plotly is actually cross-platform, and it does more of the interactive type stuff. But like a lot of the things I'm showing right now are just sort of static graphical things. But if you wanted to do more dynamic things, Plotly would be something to explore for either R or Python. So that might be something to consider. But Matplotlib is kind of, I think, another good sort of starting point. It's the default plotting backend for Pandas for what it's worth. So now here's where like it gets mushy. Tools are interoperable. RStudio has added support for Python because a lot of people go back and forth between those tools. And then Jupyter, which I didn't demonstrate today, but the Jupyter notebook, it actually stands for Julia, Python, and R. So there's kernels is what they're called for Python, R, and Julia. So if you were to install either tool, you could do either language. So RStudio is kind of de facto for our work, Python, there's more of a diffuse sort of tool set out there, only because there's, depending on what you're doing, but notebooks are pretty standard for data science in terms of exploration. So which language? Okay, this is definitely not definitive. This is my opinion. This is my background. As you can see, I started in R. So I'm biased towards R as my first place if I want to get stuff done quickly. So R, I think, is best for sort of pure data cleaning, analysis, and visualization tasks. So Pandas can do all the same things. There's a large ecosystem of packages, especially suitable for data analysis. So when I was in grad school, for instance, M+ was the thing that they asked us to use for structural equation modeling. Well, M+ is $800. For my dissertation, I went out and got a package called Laban, L-A-B-A-A-N, which there's latent variable something analysis in there, which cost me all $0. So it's less finicky to install and update. Whereas Python, it's general purpose. You can perform tasks in other broad domains such as web development, game development, etc. So the whole world's open to you in Python. But most of the popular tools for machine learning and big data, such as TensorFlow, Torch, etc., have Python implementations, though R is starting to get access to those as well. So let me tell you, here's some real world things I've done with Python. I've web scraped my kids' swim league results to create a data set to strategize event selection for league championships. I'm building an LCAP analysis web application with a Python backend API. I found a package from NASA, so I connected over here. You can't see. I've got a set of faders for when I did music production and as a music teacher. And so I connected the faders on that to X-Plane, which is a flight simulator to control the throttles on a virtual B747. And another thing I've done for work is for our 23 districts, I've automated download of CalPAS extracts. So Python is really flexible. So now what do we do about Excel? Okay, so I've got a suggestion for Excel here. It's my last animation in here. So what do we do about Excel? Permanently delete. No, I'm kidding. That's a lie. I do not suggest losing Python or Excel from your workload. So Excel has its place for one-off analysis. If you need a quick turnaround, like how many of you have gotten, oh, I need this graph for tomorrow for a presentation. Just throw in Excel, clean up the graphs, and call it a day. Excel definitely has a place, but it's just not as reproducible. So if you have to do something over and over, that's where you might want to consider some of these other tools. So here's some downloads. I'm going to go through this pretty quickly because, as usual in these things, that my time is going to run out pretty soon here. Official downloads for R and Python on this slide. Anaconda is kind of integrated. It includes R, Python, and Jupyter all in one bucket. So it's not a bad place to start with data science. And then other IDEs for maybe Python might be VS Code or PyCharm, but those aren't as data oriented. They're more general purpose programming oriented. Here's some resources on R to learn R. I'm a big fan on GitHub of all the awesome sort of repositories. So it basically it's a link to all the lists in the world you could ever think of. Some key packages I use a lot. So I didn't demonstrate this, but in R, one of the more popular package sets is called the Tidyverse. And so the Tidyverse, it replaces some of the default behaviors within R, but I think they expose a better way to do visualization and data manipulation and pulling in data. But and then R, Pandas is the de facto package for data manipulation. Requests from Beautiful Soup will help you to do web scraping, and Matplotlib for data visualization. So I've got just a quick few slides on Knime. Knime lives between Excel and R and Python in complexity. It's visually based, has many of the advantages of reproducibility that come with the other tools. And it might actually be a first consideration because it's got a lower barrier to entry. It's Java under the hood, so you can still do some programming. You can integrate R, Python scripts into Knime, and NimePy can go the other way. So, instead of having to type out each of the steps, it's more like these sort of building blocks that do the work. So I won't cover it extensively, and I don't know it as well, to be honest. Steve Aon, who's on the call, showed a pretty extensive workflow in just about 10 minutes. So you can click on that video on your own time to take a look at it. Actually, I might come back to showing a more complicated data flow in these tools just because of time. Okay, so interactive visualization tools. And I'll try to pick up any other questions at the end because I've got about 5 minutes. So Tableau and Power BI, both tools can do all the things. They can do some of the things you saw before, ingest data, manipulate data. Tableau has Tableau Prep. Power BI has Power BI Power Query Editor, which is actually being integrated into Excel. So you can do the same sort of workflows within Excel. It's just, so if you do have like a text file, you can do that sort of thing. You can create interactive visualizations. You can share those visualizations to others. Tableau Cloud, Public, Power BI Service. Apparently I had another thought I never got to. So some considerations there. Tableau probably is a more mature tool and it's got better functionality, but there's a cost associated with it. Power BI, I think, has less visualizations, but it has the distinct advantage of being included with many of our Office 365 subscriptions. So, and that's important because it facilitates sharing data with end users, especially if you have to protect it from the outside. So if you have an Active Directory sort of infrastructure and it's already cloud-based to some extent, then that really helps. Access control is such a mess in terms of some of these tools with private student data. So, and if you have any other thoughts, throw them in the chat for each other because I don't have a lot of time to cover these tools. And then the presentation on Google Studio, Data Studio, reminded me that it existed, and I actually use it for one of my more recent visualizations. It's included as part of any Google account. So it's very similar to other Google offerings. It's pretty good for the price, less overall features and less flexibility, just like slides here. You know, it doesn't have all the features of PowerPoint, but it gets 80% of the job done, just like Docs with Sheets, etc. Due to its free nature, it's also subject to Google's ruthless approach to unwanted projects. So you might remember such fun things as Google Reader, Google Plus, Google Expeditions, Google Print, Google Play Music, Google Fusion Tables, Google Picasa, iGoogle. So, I mean, I don't think it's going anywhere, but you never know with Google. Like if they lose interest in a product or they don't think it's working, they are willing to get rid of certain tools if they see the need. So, what I would say in the visualization world is that if you're just starting Power BI or Data Studio for the price of entry, Tableau if you become a more sophisticated visualization creator. And of course, you can do all these interactive things within Python and R using Shiny or Plotly or whatever else. But that's a deeper dive and a lot more work, but a lot more flexibility. Okay, Docker was on my list. This is even briefer. I've got 3 minutes. So Docker is a technology to create containers, and it's a lightweight environment in which programs are executed in isolation from the rest of the environment. So it allows dependencies to be included, and you don't have to worry about conflict with the main OS and its libraries and tools. So I'm going to skip that. They're ephemeral. So you start a container, it has Python built in, you do some work, and then you delete it and it's gone. So the nice thing about it is if you have a process you're going to do over and over, you have to make sure everything's included in the definition of the container. And then it helps with scalability. So if you need to do it across, like you're serving Instagram and you need to have 1 million web servers. So where it's good in your use case as maybe a data scientist is you can try out different tool sets without having to perform a full installation. So there's Docker images for Python, there's Docker images for databases, and there's a video on that. Okay, so that, because Docker was in the title, I talked about it, check. Alrighty, so this is what I showed you at the beginning, and that was a lie, right? The real reality is these tools, they overlap, they do a lot of the same things. And so here's my suggestion. Don't let choice paralysis prevent you from picking a tool to try out, just pick one and go. Don't learn it in a vacuum, apply it to a real world task, and that will be the best way to learn. Have a growth mindset that will take way longer the first time than falling back on your normal process. And eventually you'll end up treating these tools as solutions to every problem you saw. When my kids in their pool meets, I use it to help make decisions. Here's another XKCD though. So you spend a lot of time on a task, you should write a program to automate it. Well, here's the reality, right? It takes more time in the beginning, and over time, automation takes over and you build up more free time. Reality is sometimes you don't save time, but it's fun along the way. So once again, all these tools with the exception of Excel, Power BI, and Tableau, well, Power BI is free through your district most likely, or LEA. They're open source and consequently free. That's contributed to the large universe of packages and other tools around these tools. And in future out years of budget constraints, free is a huge plus. So if you have any questions, this is my contact info. That's me in my office. That's an artificial tree. Otherwise, it would look a lot more brown nowadays because I haven't been there. And then now here's the bad. I do want to show you one aspect in which data science is bad. So Google Slides has an autocomplete feature where it tries to predict what you're trying to say. So one of my slides, I made a typo. And so machine learning isn't always a solution to every problem. I was not interested in talking about my opioid addiction. And that is my presentation. Thank you all for going on this whirlwind journey.